In the previous video, we had discussed about the shapes of organic molecules and we learnt about hybridization of the carbon atom and the various shapes of these molecules. In this video, we are going to be discussing the in-text questions of the same. First one, 12.1. How many sigma and pi bonds are present in each of the following molecules? So, there are two ways you can do it. You can look at this molecule and then figure it out on the basis of counting, or I feel like it might be easier if you are able to write the structural or the condensed structural formula, and then which we will be discussing in the next topic. But I feel like maybe if we introduce bonds and such, it'll be easier for us to count these. Okay, so the first one is HC. Then you have a triple bond between the two carbon atoms. So I'll write the triple bond. Then you have another carbon bound to a hydrogen, which has a double bond with the carbon bound to a hydrogen and a CH3. Okay, so CH3 can be written like this, or if you're more comfortable, just open up the structure. So this way it's easier for you to basically write the number of sigma and pi bonds. First of all, let's talk about the sigma bonds between carbon and another carbon. So sigma CC. Okay, so here you have 1, 2, 3, 4. 4 sigma bonds between the between two carbon atoms. Now we have to consider the sigma bond between a carbon and a hydrogen. We just have to count the number of hydrogen atoms. So 1, 2, 3, 4, 5 and 6. So you have 6 CH sigma bonds. So the total number of sigma bonds in this structure is 10. Okay, the next are the pi bonds. So in the double bond, you have here a double bond here and you have a triple bond here. In a triple bond, you have 2 pi bonds. Okay, whereas in a double bond, you have only 1 pi bond. Okay, so which means, first of all, let's write a pi C double bond C has 1 pi bond, whereas pi C triple bond C will have 2 pi bonds, because one is sigma, the remaining 2 are pi. As we learned, they use up the unhybridized p orbitals for this particular type of bonding. Okay, and so the number of pi bonds in this molecule is going to be 3. So first we opened up the structure and then we just counted it. All the single bonds, you need to remember, all the single bonds will be sigma bonds, first thing. Second thing, each of double and triple bond will have only 1 sigma bond. In case of pi bonds, double bonds will have 1 pi bond, a triple bond will have 2 pi bonds. Let's look at this structure. Again, it's up to you. If you are comfortable enough with directly writing it, it's completely fine. But I feel like since you're starting to learn about organic chemistry and all of that, it might be easier if you opened up the structure. So CH2 double bond C double bond C CH2. Okay, so here let's look at the sigma bond. So sigma, you have a CC bond and you will have a sigma CH bond. In case of CC, you have 1, 2, 3 CC sigma bonds, whereas CH 1, 2, 3 and 4. So you have 4 sigma bonds. So the total number of sigma bonds, oh, I am so sorry, here I made a mistake, sorry, CH 1, 2, 3, 4, 1, 2, 3, 4. So 1, 2, 3, 4. I'm so sorry. This is supposed to be a CH3, right? Yeah. So the number of CH bonds is actually 6. So 1, 2, 3, 4, 5 and 6. So 6 plus 3 equals to 9. Okay, I just wrote the question, I copied it down wrong. So CH3. Okay, now in case of pi bonds, pi C double bond C. You only have C double bond C over here, you don't have triple bonds. So you have two double bonds, which means there are two pi bonds. So in this molecule, you have 9 sigma bonds and 2 pi bonds. Okay. Next, what is the type of hybridization of each carbon in the following? Again, it's up to you. If you want to, you can write the complete structure, or if you don't, you can just, predict the hybridization of these atoms. But for me to explain it to you, I would prefer if I wrote the structure. Okay, so CH3Cl. So CH3Cl. Now, if you notice, this carbon atom, it is only having single bonds. It is only surrounded by single bonds. It's only bound by single bonds, and this means that it is sp3 hybridized. So sp3 for single bonds, basically sp2 if you have double bonds, and sp for triple bonds. Okay, and this is why you have pi and sigma coming up, right? Next, CH3 taken twice, CO. Now, CH3, CO, CH3. Now, we need to see what kind of what is the hybridization for each of these. Now, if you notice, this carbon atom and this carbon atom, both of these are forming only single bonds. Hydrogens will be able to form single bonds only, right? So 3 plus 1 equals to 4, which means they have formed single bonds only. So its hybridization is going to be sp3. However, the carbon over here, it's bound to oxygen. It has how many bonds? 2 bonds, which means its hybridization will become sp2. Next one, CH3CN. So CH3 C triple bond N. Now, again, this carbon atom, 3 plus 1 equals to 4, which means it has formed only single bonds. So its hybridization is going to be sp3 and C triple bond N. So it has a triple bond, which means its hybridization is sp. Next, D. COHNH2. So HCONH2. So I'm able to write these structures on my own because I have a basic idea behind functional groups. Don't worry. For now, you need to remember that oxygen will form a double bond. Nitrogen is going to form a triple bond, and that's exactly what we followed. And when you understand about functional groups and you learn them, you will be able to do this on your own. So here, the carbon has a double bond, which means it is sp2 hybridized. And the last one, E, you have CH3, CH, okay, you have a double bond over here, CH, C triple bond N. Now, the first carbon, it's going to be sp3 hybridized. Now, this carbon and this carbon, both of them have a double bond each, right? Both of them have a double bond, so that will be sp2 hybridized, whereas this carbon has a triple bond, which means it is sp hybridized. So that's about it. We just counted the double bond. If the particular carbon atom had double bond or a triple bond or a single bond means sp3, double is sp2, triple is sp. Now the third question, write the state of hybridization and shapes of each of the molecules. Now the first one, here you already have a double bond between the carbon and the oxygen. This means that the carbon is sp2 hybridized. Okay, and because it's sp2 hybridized, its shape is going to be trigonal planar. Next, CH3F, this, so fluorine, okay fine, 3 plus 1 equals to 4, which means this carbon atom is bound to 4 other atoms, which means it has only single bonds. So hybridization is going to be sp3 and the shape is going to be tetrahedral. The third one, you have CH triple bond N, which means the hybridization is sp and the shape is going to be linear. So all these questions have are to do with the hybridization as well as the shape. You need to remember single bond sp3, double bond sp2, triple bond sp. And in case of a double bond, you have a sigma and a pi bond. In case of a triple bond, you have 2 pi and 1 sigma bond. Single bonds are always going to be sigma bonds. So in the next video, we will be discussing about the structural representation of the organic compounds.